Hello, we will be reviewing solving equations today. And this is something from algebra, so if you've taken algebra, you should be familiar with this concept. All right, we're going to title the top of our page, Solving Equations Review. And go ahead and put the date there for yourself. And first we're going to start by defining some terms or giving examples for these terms. So the first term is equation. All right, and our equation example is negative 5x plus 3 equals negative 17. All right, that's our equation. From this equation, we're going to break it down into smaller parts. Next, we have the terms. Terms of the equation. These are the parts that are separated by addition, subtraction, or our equal sign here. So we have our three terms here. The terms are negative 5x, 3, and negative 17. Next, we have our coefficients. Coefficients are the numbers in front of the variable. We just have one coefficient here, which is 5. And next, we have constants. Constants are our regular numbers without a variable. That would be 3 and negative 17. And then finally, I've referenced it a couple times, but let's get to that variable. And the variable here is x. X does not always have to be the variable in an equation. It can take on any letter. Okay, next we're going to talk about inverse operations, which is what you need to solve an equation. Inverse operations. Okay, so inverse operations work in pairs where they are inverses of each other. We have multiply and divide. These are opposites, inverse operations, and we really don't use our X symbol for multiply very much, or even our dotted kind of slash here for divide. Typically for multiply, we'll see a dot hovering above, not like a decimal, but hovering, or we might see, so let me actually make that a full example, like 2 times 3, like that. We also might see parentheses, 2 times 3. And then for divide, we typically see it written as a fraction, something like x over 4, x divided by 4. So those are two inverse operations. Next we have add and subtract. And those symbols are not a surprise. We have addition and subtraction. Subtract is also working like adding a negative. So we might see negatives, we might see subtraction signs, and we can kind of treat those the same. All right, we have our inverse operations, and then last thing to talk about before we start solving is what is our goals when we're solving. First, we want to isolate the variable. Isolate the variable. And that means get that variable by itself. Move everything away from it so we can isolate it and figure out what it is. Second, our goal is to stay balanced. When we are solving equations, we need to make sure whatever is done to one side, that same operation is done to the other side of the equal sign in our equation. Okay, so we have a couple, we have a couple examples we're going to do, starting with that equation I had where we broke it down. So that was negative 5x plus 3 equals negative 17. Now what I like to do to show the two sides that I need a balance in my equation is draw my vertical line through the equal sign. From here I can think of my operations and start doing the inverse. So I have plus here, 3 here, and the inverse of that is to subtract 3. So what I want to happen on the side with the variable is I do want that number to go away basically. So we're saying we cancel it. It's 0. So it's now gone on that side. And I'm essentially moving it over here from the inverse, and then I want to collect these together. So negative 17 minus 3, or think of it as plus 2 negatives, which will be a negative, and I should add them together, 20. All right, next we will see we have multiplication here, and the inverse of that is to divide. So divide both sides by 5. Again, I get my cancellation here, and that's because negative 5 over negative 5 is equal to 1. And 1 times x is just x. And then finally over here, negative 20 divided by negative 5 is negative 4. Negative 4. I can always check my work by taking that number and plugging it back into the equation. Negative 5x, instead of x here, I'll put negative 4, so times negative 4 plus 3, and that should equal 17 for me. Negative 5 times negative 4 is going to give me that positive 20 plus 3. Ooh, and see what I'm doing is I'm seeing that I made a mistake. And that is because a negative divided by a negative is actually a positive. So I should be using a positive 4 here. And I wouldn't have noticed if I didn't start checking my work. So now negative 5 times positive 4 plus 3 should equal negative 17. I do get my negative 20 here plus 3. And that is in fact true. I'm going to do my subtraction. This time there are more negatives, so my answer is negative, and 20 minus 3 is 17. Negative 17 equals negative 17. It checks out, and that tells me that I found the correct solution for x. All right, let's try another one here. X plus 4 over negative 12 equals 10. All right, so typically we do want to undo our addition or subtraction first, like we did in number 1. But in this case, we have everything here, x plus 4, on this side being divided by 12. So this is the cases where I would typically want to deal with that division first. We talked about the opposite of division being multiplication, and I'm going to multiply by exactly that number that is being divided. It's going to end up canceling out for me here. For the same reason, negative 5 over negative 5 is 1. I get negative 12 over negative 12. On that side, I'm left with x plus 4. And then over on this side, I get 10 times negative 12, which is negative 120. I go on with my solving. Now I can take care of that addition by subtracting from both sides. And I get x equals negative 120 minus 4. I'm really going to add those together and get negative 124. You could go ahead and check our work on this. I'm pretty positive on this one, and it's good to do that practice. So if you want to pause the video now and do that, go ahead and check our answer. All right, I'm going to move on and do just 2 more examples here. So let's get on with example number 3. I have negative 20 equals negative 4x minus 6x. So this is one of those cases where I want to go and simplify my like terms first. So if I notice I have 2 variables on one side or 2 regular numbers, constants, I want to put them together before solving to make the least amount of mistakes typically. So I know negative 4 and negative 6, I'm going to add the coefficients here, negative 4, negative 6, and that leaves me with negative 10. It's still negative 10x because I'm dealing with x's. Now I can go into my solving, and I just have one step left here, which is to divide by negative 10, and I get 2. Positive 2, and I can always flip that around to put x on the left if that's what I prefer. It is fine to leave it in this way also. Alright, and we are making it to our last example. Alright, we have some parentheses here. Remember, parentheses mean multiplication. We want to multiply the number on the outside to both quantities on the inside. So 7 times x, I'm going to get 7x, and 7 times negative 1 is negative 7. So now I've taken care of that multiplication. I can move on with my like terms. In this equation here, I have constants as my like terms. I'm going to add my constants together, negative 7, positive 3, and that's going to give me 7x minus 4. Now I am ready to start solving. I'm going to add 4 to both sides. Cancels here. I get 7x equals 21. Last, this is multiplication here, so I will divide, and I get x equals 3. Alright, and that concludes our review of solving equations. We will be using this in geometry lessons throughout the year.